Hello and welcome to the fourth installment of Hotard's Algebra 2 instructional videos, home of all things Algebra 2. Today I'm coming to you from my son's treehouse. It's such a nice afternoon that I decided, let's do an outside video. Many of you in the past have asked me on nice days, Mr. Hotard, can we have class outside? Today the answer is yes. Yes, you can. We're going to be solving exponential equations today, so let's get started. Okay, this is a two-part lesson on solving exponential equations. That's equations where the variable is in the exponent. All right, today we're going to be looking specifically at what's called the same base method, solving equations with the variable in the exponent by finding the same base. Tomorrow we'll be looking at a different method. It'll use logarithms, what we were learning about last week. So this shows up a fair amount on ACT, and also there are some real life applications that apply to this that we will look at tomorrow. Today, let's just get started with how do you solve equations with variables in the exponent using the same base. So example one is pretty easy. Example one, you notice they have a 6 on both sides of the equal sign. So when I have the same base like this, and they're equal to each other, that means the exponents have to be equal to each other. So that means I could just solve 3x plus 6 equal to 4x minus 5. And then that's just solving a basic equation like what you did in junior high. I need to get these x's together, so I'm going to subtract 3x from both sides. It's going to give me 6 equals, that's going to be x minus 5, and solve for x. I'm going to add 5 to both sides. Gives me x equals 11. Not hard. All right, as long as I have the same base, I could just set the exponents equal to each other and then solve that equation. And then just to check, I can check to make sure it works. If I plug in 11 times 3 gives me 33 plus 6. I got 6 to the 39th power. Over here, 11 times 4, 44, minus 5 also gives me 39. Get the same thing on both sides of the equal sign, so it works. Example 2. Now this one, got some extra stuff in here. Before I try to set anything equal to each other, you notice I have 4 to the x plus 5. I have this extra times 6. Now don't try to multiply 6 times 4. The 6 does not have this exponent on it. But I need to get rid of this times 6. What do you think I could do to get rid of this times 6? I could divide by 6, both sides. So that's going to leave me with 4 to the x plus 5 equals, now 96 divided by 6. You can use your calculator if you need it. 96 divided by 6, going to give me 16. So 4 to the x plus 5 power equals 16. Now, I've got a little bit of a dilemma because the last problem I had the same base on both sides. I don't have that here. But I can rewrite, and this is going to happen a lot in these problems, I can rewrite one of these, the 16, as 4 to the what power? Not the 4th power, it's 4 to the 2nd power. 4 times 4 is 16. So I'm just going to rewrite this as 4 to the x plus 5 equals 4 to the 2nd power. And now I can solve it just like the last problem. Same base on both sides of the equal sign, so just set the exponents equal to each other. X plus 5 equals 2. And so solve that little equation, subtract the 5. That means x is going to equal negative 3. All right, and again, I can check just to make sure. If I plug in negative 3 plus 5 gives me 2. 4 squared is 16. 6 times 16 will give me 96. It does work. X equals negative 3. All right, so let's look at 2 more. These are going to be kind of similar. If you look now at example 3, all right, I'm going to have to do something similar here because you notice these are not the same bases. All right, I've got a 5 and I have a 125. But I can rewrite 125 as 5 to some power. Let's see, 5 times 5 gives me 25, times another 5 gives me 125. So I can rewrite this as 5 to the 3rd. So this is 5 to the 4x equals 5 to the 3rd. Now, I already had an exponent right here. This x minus 1. So I'm going to put that right here. Now, if you remember your laws of exponents, power to power, what do I need to do with this 3 and this x minus 1? Do I add them or do I multiply them? I'm multiplying. I can distribute that, not just the x though, it distributes to the whole x minus 1. So really this is like saying 5 to the 4x equals 5 to the 3x minus 3. Now I have my same base, so I can go ahead and set my exponents equal to each other. So I'm going to say 4x equals 3x minus 3 and solve that equation. Get these x's together. I'm going to subtract 3x from both sides. Going to leave me with x equals negative 3. All right. So there's my answer. Let's look at one more problem. Example 4. All right, this one's a little bit more complicated because I have 1,000 on one side, I have 1 over 100 on the other. Now this one, I'm actually going to have to rewrite both sides because I don't know how to rewrite 1 over 100 as 1,000 to some power. All right, but usually when a number is ending with a bunch of zeros, it means you multiplied what number to get it? 10. All right, so this 1,000, this is 10 to the, let's see, how many zeros in 1,000? 3, so that's 10 to the third. All right, then I still have that x minus 8, so I'm going to have to distribute that like I did in the last problem. And then over here, now 1 over 100, that's 10 to the, remember what kind of exponent makes it a fraction? A negative exponent. So this is 10 to the negative, and how many zeros in 100? 2. 10 to the negative 2. And then there's still that x. All right, so I'm going to have to distribute, just like the last problem, I'm going to have to distribute this 3. I'm going to have to distribute this negative 2 to this x. And we can go ahead and drop the 10 since we have the same base. So I'm going to be solving 3x minus 24 equals, over here I'm going to have negative 2x. So let's just solve this. Let's move this 3x over here. I'm going to subtract 3x. Negative 24 equals, that's going to be negative 5x. And then divide by negative 5. Cancel that out. So 2 negatives is going to give me a positive. And then I could leave that as 24/5. That's fine. I can't reduce that. X equals 24/5. You could type it in your calculator. All right, and that would be 4 and 4/5, so 4.8. That would be fine too. But the fraction is fine. You can just leave it as 24/5. All right. There are 2 more examples we're going to look at, but what I want you to do right now, I want you to pause the video, and I want you to open up that worksheet that I posted. All right, there's a lot of problems on here. I want you to try to do the first 8, 1 through 8, using that same base method. A few of them already have the same base, like number 2, but most of them you're going to have to rewrite as something to some power, and I do want to give you a hint. The ones that have 1, remember, any number to the what power gives you a 1? 0. So for number 1 on that worksheet, rewrite this 1 as 4 to the 0 power. This is 4 to the 2x plus 3 equals 4 to the 0. All right, so then you have your same base. You could set them equal to each other. So I want you to solve, again, 1 through 8, and then pause the video and check the answer key. Make sure you got those done, and then come back and finish the video. Did you do it? Of course you did. Why would you not? Okay, so now let's look at our last 2 examples. Last 2 examples, these, we're going to have to bring in something that we learned about last week. All right, if you look at example 5, 4 to the 3x times 4 to the 5th equals 64. All right, first of all, how is this problem different from all the others that we've done so far? Over on this side of the equal sign, there's more than one base. There's more than one number that has an exponent on it. So I'm going to have to do 2 things. I'm going to have to use my laws of exponents to combine these. All right, this is 4 to the 3x times 4 to the 5th. When it's multiplication of same bases, do you remember what you could do with these exponents? You don't multiply them, you add them. So I can rewrite this as 4 to the 3x plus 5. I'm doing that because I had 2 4s on this side of the equal sign, so I combine them. Equals, now over on this side, I can rewrite 64. All right, that's going to be 4 to the, now 4 to the 1 is 4. 4 times 4 is 16. And then times another 4 gives me 64. So that's 4 to the 3rd. So now I'm ready to solve that equation. I have my same base, so I'm going to write 3x plus 5 equals 3. And I'm going to solve that. Subtract the 5. 3x equals, that's going to be negative 2. And divide by that 3. Cancel that, so x equals, that's going to be negative 2/3. Fractions are okay. You can get fractions. Fractions are our friends. All right, and then the last one. Uh-oh, there's a fraction of the problem. That means you give up, right? Well, not necessarily. There is always the possibility of cheating off your neighbor. Oh, wait, you're in quarantine, you can't do that? I guess you're going to have to learn how to do this problem from me then. Okay, so again, I want to have the same base everywhere. So let's just go through and try to rewrite everything as a 5. The 5's already on bottom, but 125, that we said that's 5 to the what? 5 to the third. So that's 5 to the third, and then we have over 5 to the x, that's still the same, equals now 25, that's 5 to the what? To the second power, 5 to the 2 power. All right, so just like the last problem, how we had 2 4s on the same side of the equal sign, it was multiplication, so we added the exponents. In this problem, we have 2 5s on the same side of the equal sign. It's being divided. So what do you think we should do with these exponents? We should subtract them. I can rewrite this as 5 to the 3 minus x equals 5 to the second power. Now again, same base, so I can drop the 5s and just solve the exponents. 3 minus x equals 2. Get the x by itself. Subtract 3. I've got negative x equals negative 1. And just divide both sides by negative. That means x is going to be positive 1. And again, you could always check to make sure it works. If I plug in 1 right there, 5 to the 1 is 5. 125 divided by 5 will give me 25. It will work. All right, so that is solving using the same base method. I want you to go through now and finish the rest of the CUDA page, that extra practice page that I posted. Again, the answers are on bottom. If you scroll down to the very bottom, you could see just the answers. If you look at my answer key I posted, I actually posted the work with it, so you could use that if you get stuck. And again, email me if you have any questions. All right, I check my email every day, Monday through Friday, 10 to noon. So you can get a quick response from me then. If you email me later than that or during the weekends, I will still get back to you. It just takes a little bit longer. All right, so tomorrow we're going to get some more practice with this, and we're going to be looking at a different method for solving exponential equations. All right, I know you're excited about that, but you're just going to have to wait a day. I will talk to you again later. Y'all have a great day. Bye-bye.